Alright guys, welcome back. So today we're going to work on the 10-1, 10-3 review. I'll post a blank copy of the review worksheet along with my answer key to Google Classroom. I'm just going to pick and choose a few of the problems that I know in the past either stump some students or students always ask questions on these specific question or problems, but the majority of it I'm going to leave for you to try on your own, and then you can compare your answers to the answer key and let me know, email me if you have any questions. All right, so the first six are a vocab base. I'm going to leave those for you to do. If you take a look at number 7 and 8 with me on your review worksheet, it says, is a tangent shown in the diagram? Show your work to support your answer. Okay, so I'm actually going to do both 7 and 8. So for problem 7, you're given this circle, all right, circle K, and then we have a radius, which is 6 units long. All right, you have this other segment, which is 8 units long. And then this segment here, which is labeled as 10 units long. And you're asked to determine whether or not this segment is tangent. Okay, well, if it is tangent, we learned that the tangent and the radius meet at the point of tangency and are perpendicular to each other. So if this segment is tangent, you would have a right triangle here. So to determine whether or not this segment is tangent, we're going to see if that is a right triangle. And to determine if it's a right triangle, we use Pythagorean theorem. Okay, that was from last chapter. So a squared plus b squared equals c squared will tell us if this is a right triangle. All right, your C has to be the longest. That would have to be the hypotenuse. So that's going to be 10. So you have 10 squared. And your A and your B, it doesn't matter which one's A and B, but I'll write 6 squared plus 8 squared. Okay, and you're just going to go ahead and simplify and see if both sides of the equation are the same. So you're going to have 36, 64 equals 100. 36 plus 64 is 100. So it is a right triangle. Okay? Since it is a right triangle, that means that yes, a tangent is shown. Yes, a tangent is shown. Okay, that segment there is tangent. All right? We're going to do a similar problem, but the math is going to just be a little bit different. So let's look at problem number 8 together. All right, so problem number 8, we have a circle, circle A. You're given radius AB is 8 units long. Right, then this segment here, BC, is 10 units long. And then CA, that segment there, is 4 root 10. So it's the same question. We're asked whether or not CB is a tangent. So if it is, that means I would have a right angle here, which means I would have a right triangle. So we're again going to check Pythagorean theorem. Okay, so a squared plus b squared equals c squared. Your A and your B are 10 and 8. Your C is 4 root 10. So I have 8 squared plus 10 squared equals 4 root 10 squared. All right. So 8 squared is 64. 10 squared is 100. Now be careful here. 4 root 10 squared means you have 4 root 10 times 4 root 10, or you're going to square the 4 and square the root 10. So it's kind of up to you how you want to think of it, but you have to square the 4 and square the root 10. Okay, so 4 squared is 16, and then root 10 squared, well, square and square root undo each other, so you're just left with 10. Okay. So I can carry this down. 64 plus 100 is 164. And we're checking to see, does it equal? Now I have 164 is equal to 16 times 10, 160. So they are not equal. So that means it is not a right triangle. It doesn't work in Pythagorean theorem. So my answer here is no, a tangent is not shown. All right. So that was problem 7 and 8. We're going to next go to problem 9. All right. So for problem 9, you're given this circle, circle C, and you're given two tangents that start from the same outside point of the circle, okay? And they are labeled x squared plus 3x and 10x minus 6. All right, we learned in an earlier lesson that if you have two tangents that originate from the same outside exterior point, those two tangents are equal to each other. They are congruent to each other. So I can set them equal to each other. X squared plus 3x is equal to 10x minus 6. Now this equation, because there's an x squared term in the equation and it's not going to be eliminated in any way, it's not going to cancel with another x squared term, I know it's quadratic. And when my equation's quadratic, I want to set it equal to 0 and then try to solve by factoring is always the best method. So I'm going to move the 10x over first by subtraction. So I have x squared and it's going to be negative 7x equals negative 6. All right. Then I'm going to bring the 6 over by addition. So add 6 to both sides. So I have x squared minus 7x plus 6 is equal to 0. Okay, so you have to remember your algebra 1. It is a trinomial. We're going to factor what two numbers multiply to give you, or what two terms multiply to give you x squared? It's x and x. What two factors multiply to give you 6? It's 2 and 3, okay? Or 6 and 1. And you need a sum of negative 7. So I know it's going to be a negative 6 and a negative 1, because negative 6 times negative 1 multiplies to a positive 6, and negative 6 and negative 1 adds to a negative 7. All right, then you're going to use the zero product property. Let me bring this down just a little bit. You're going to use the zero product property, set them each equal to 0. And solve for x. So I have x is equal to a positive 6, x is equal to a positive 1. Okay? Now, you can double check by plugging them back in to make sure that they both work. They do. I would definitely be cautious if you get a negative answer, because if x is a negative value, plug it back in. Make sure it doesn't give you a negative length for a piece of your circle or a segment of the circle, right? Because that would not be a correct answer. All right, let me get back up to the top. Oh, hold on a sec. Okay. All right, so that was problem number 9. I'm going to just look at the setup for 10, but I'm not going to work 10 out completely. All right, so for 10, we have a circle. It's circle O. You have a radius labeled as x. You have another segment, and it's labeled as x and then 8. And then you have 12. Okay, so it actually looks similar to some of the diagrams we were looking at earlier today. Now, if this radius and tangent meet at the point of tangency, I know it's going to be a right angle, okay? And I can, again, use Pythagorean theorem to solve for x. Now, keep in mind, let me just move this out of the way. Keep in mind that this side of the triangle has to be written in an expression right? That includes this piece and that piece. So the entire length would be this piece x plus that piece 8, or x plus 8. Okay. So when you set up Pythagorean theorem, a squared plus b squared equals c squared, your a and your b, x and 12, so x squared plus 12 squared, is equal to your c, your hypotenuse, which is the x plus 8. So it's x plus 8 squared. And then x plus 8 has to be in parentheses because you do have to FOIL. Make sure you write it out as x plus 8 times x plus 8. You cannot simply square both of these. You won't get the right answer. All right, so I have x squared plus 144. And then this is where I'm going to stop and let you guys finish it up. Okay? All right. The last two problems on the front give you a diagram, and they ask you to name a major arc and a minor arc. You'll see in my answer key I have stars because those are just examples. Just keep in mind major arcs should be 3 letters, and the arc should be greater than 180 degrees. A minor arc should be 2 letters and should be less than 180 degrees. And then a semicircle should be exactly 180 degrees and again be named with 3 letters. Okay, so multiple answers for those, but you can check my answer key. All right, jumping over to the back. Actually, I'm just going to do one problem with you. I just want to look at number 18, the last one. The rest I think you'll be okay with. So number 18, you're told that ON is equal to OK, which is equal to 12. And then it says AB is equal to 3x plus 5. CD is equal to 6x minus 22. And we want to find the radius. We also have a diagram, so let me draw that next. So we have circle O. And then you're given this chord, AB. You're given, and there's a right angle, I believe. I think it's there. I don't think I added that in. Okay. Yes, it was there. And then you're also given CD and ON. Okay. All right. So that is the diagram you're given. All right, we're going to label what information was given. So it says that ON, OK are both 12 units long. So first thing I'm going to do is I'm going to label them each 12. I'm going to mark them congruent. Now we learned in an earlier lesson that when two chords, I'm talking about chord AB and chord CD, when they are the same distance away from the center, they're both 12 units away from the center, that means the chords are congruent to each other. So I know that this chord AB is equal to this chord CD. Okay, so that's something to keep in mind as well. Also, we learned that when you have this segment perpendicular to the chord, it's bisecting the chord. So I can put 2 tick marks on all 4 of those little segments because AK, KB, CN, and ND are all congruent to each other. All right. Now, you're told that AB, right, can be written in the expression 3x plus 5, and CD is 6x minus 22. Well, we just said that those 2 chords are equal to each other, so maybe I set the expressions equal. Maybe that's going to help me at some point. 3x plus 5 is equal to 6x minus 22. All right. Now, the directions ask us to find the length of the radius. Okay, now I'm going to have to sketch a radii into my diagram. And I could sketch it anywhere, right? Like I could sketch one over here. That's a radius. I could sketch one down here. But what I actually want to do is I want to sketch one so that I form a right triangle somewhere in the diagram. Here, I could have done one here and looked at this right triangle, or here. Okay, so lots of different options. All right, so the goal eventually is to find this length here. But let's go back and solve for x. We set up this equation. Let's work with it for a second and get a piece of information that might be helpful. We're going to solve for x. So subtract 3x from both sides. So I have 5 is equal to 3x minus 22. All right, I'm going to add 22 to both sides. So I'm going to have 27. Oh, I wrote 27, sorry. 22 gives you 27. It's equal to 3x. Then I'm going to divide both sides by 3. And that leaves me with x is equal to 9. Now that's not the answer. Remember, we're trying to find the length of the radius, but that's going to help me. All right, so now that I know x is equal to 9, let's take a minute and figure out the length of AB. Okay, so AB is equal to 3x plus 5. So I have 3 times 9 plus 5. You're going to have 27 plus 5, which is going to give you a length of 32. Now, I can plug in 9 here, and it will also give me 32. Okay, so if this segment AB is 32, and this segment CD is 32, what's the length of just AK? And what's the length of KB? Well, you're going to take 32 and divide by 2 to get 16, 16, 16, 16. And now that I know that piece of information, how am I going to solve for the radius? How am I going to solve for that blue segment? Pythagorean theorem. A squared plus B squared equals C squared. So you're going to have A squared plus B squared equals C squared. 12 squared plus 16 squared equals C squared. All right, and I'm going to leave it there for you guys to finish off. That was a multi-step problem. You did have to draw this auxiliary line in for yourself, so I just wanted to work through that one with you. Okay, so go ahead, finish up the rest of you on your own, check your answers against my answer key, and shoot me a message if you need any help or have any questions. Have a good day. Bye.